factoring lunch tomorrow.
That works, yes. All right, so we are on Monday, October 14th. Today's date is Monday, October 14th, 10/14/19. Make sure your name and date are on your paper. Today's lesson is 3-5, factoring perfect squares. Friday was 3-4, factoring difference of squares. Very similar lessons here. Quiet, raised hand. Oh, did we not pass out the cards? I guess that was supposed to be the game warden's plan. Who wants to do cards? 50 XP. Beverly's hand was up first. Anna, can you please give Beverly her 50 XP for passing out the cards? Quiet, raised hand. Who can read our objective for today? Ellery.
Factor perfect squares in the form of a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared.
Perfect, yeah, so the only difference is one of them is a plus, one of them is a minus. We need to know how to do both of those. They're technically the same formula, but I'm going to make it easy for you. Jaden, what's going on? Alright, so, do you guys remember how to square the first, double the product, and square the last? Uh-oh. No?
Wait, what was that?
Do you remember how to square the first, double the product, square the last? Oscar, your laptop?
What was that?
In order to multiply to get a
I'm
perfect square, to get perfect
75%
squares?
sure.
No?
Once
Because
you
today we're going
show us,
backwards.
I will remember it.
Alright.
I'm 75% sure I know how.
So, I wonder if I can make it blink. I can. Okay, so if I had, you don't have to write any of this down, I'm just trying to show you guys. If I had something like 2x minus 5 and I was to square that, I would first square the first, 4x squared, double the product, 2 times negative 5 is negative 10x. I double that to get negative 20x. And then square the last, negative 5 times negative 5 is positive 25. In order to square this, the shortcut was to square the first, double the product, square the last. What we're doing now is we're going backwards today. I will help you with that going backwards because I know some of us still can't go forwards quite well. Leo, can you take out your AirPods, please? Thank you. So what is a square? We're going backwards now. So I want you guys to take the square root to unsquare something. So if I went from x squared to x, how do I go from 16p squared to its unsquare, to its square root? Anyone want to take a guess? Anna. 4p. There it is. Write it down. Anna has her card in now. She's giving herself 50 XP. To undo the square, to unsquare it, I now have 4 and only a p. What about 64y squared? How do I unsquare that? How do I square root it? Who still has their card? Oh yeah, Beverly. 8y. How do I unsquared m squared? How do I take the square root, India? Just m. What about 49x to the power of 4? Ooh, tricky, tricky. Brian? 7. 7x squared. There it is. Thank you, Brian. How do I unsquare or take the square root of 4a to the power of 6? At Ziri. Power, yeah, to the power of 3 or cubed. There it is. What about this really difficult one? 16c to the power of 50. Who still has their card? Who still has their card? I want to get some new people in. How do I take the square root of 16c to the power of 50, Colby? 4c to 25. All right. Thank you, Colby. Question, Anna?
How do I make Siri go away on the iPad?
I don't know.
Press the home button. Okay.
Just say Siri to go away.
Honestly, it works. It'll show up like, she leaves.
All right. So, if you are square rooting, which is what we just did, what did you do to the coefficient and what did you do to the exponent? I need 2 quiet raised hands. One for what did we do with the coefficient? You're basically saying these same words here. Ellery.
I square rooted it.
Yes, you square root the coefficient. You square root the coefficient, but what do you do to the exponent? What operation do you do and what number do you do that operation by? India.
Divide by half.
Divide by 2 instead of a half, right? Divide by 2. Divide the exponent by 2. That's the general theme of how to unsquare something. Yes. I do, but I gave it away already. The community charger has been taken. All right, so here are the 2 formulas. There's really one formula, but I'll separate it into 2 to make it easier for us. So our first formula is going backwards. I should have something squared here, and I should have something squared here. Does anyone want to take a guess as to what should go in here? If you know how to go forwards, you should know how to go backwards. I'll give it to us so we can be done with this. This is a plus b. It's that easy.
Minecraft. I'm trying to play Minecraft.
What happens if my middle term is a minus, though? That's going to turn into, Ellery?
A minus b.
A minus b. And there it is. The hard part is figuring out that you have a perfect square, because that middle term is kind of difficult to figure out. But once you know that you have a perfect square, it is as simple as square rooting the first, square rooting the last, and taking the sign of the middle term. I will show you that in an example because words probably don't help it. But before I do an example, I want to talk about our new procedure, because last time on Friday we had two possible branches. I'm adding on this third possible branch. So you always do what first? 3 letters. You factor out the, Caroline. Greatest common factor. Thank you, Caroline. And then after I factor out the greatest common factor, I will have one of 3 possibilities. First possibility is a quadratic trinomial. Quiet raised hand. What is an example of a quadratic trinomial? That sounds like really advanced and sophisticated language. We talked about this last year and this year. What is a quadratic trinomial? Give me an example. Only 3 people know what a quadratic trinomial is. Question?
Does that have to be like a quadratic trinomial that we would use in this example? That we would like use the formula on, or just random?
That's actually a good question. And it should be one that you use the formula on. Maybe I should make that one up, huh? All right, x squared plus 5x plus 6. That would be an example. That factors as x plus 2, x plus 3, so that does work. Nice. Give me an example of difference of squares. Difference of squares. Go back to Friday's lesson if you forgot an example of difference of squares. Only 1 person knows, 2 people know difference of squares. Look back at your notes. I need more than 2 people. What's an example of difference of squares? Chewy Hood. Ellery.
You have a squared minus b squared is equal to 8.
Oh, you're doing the formula down here? That's awesome. We can write that down. A squared minus b squared is equal to...
in parentheses a plus b, and then parentheses a minus.
Perfect. And India, can you give me an example that I would use?
49 minus x squared.
49 minus x squared. Perfect. So if I see a difference of squares, difference coming from the word subtract, and there's 2 squares, if I have a binomial that is a difference of squares, then you can use this formula. A quadratic trinomial, what are we going to use? This is all the way back to lesson 1. If it's a quadratic trinomial, India?
Ninja Star or advanced ninjas?
Either one, yeah. So if we don't know, we'll use advanced ninja star. And if I have a perfect square, so if you guys look ahead at the notes, you'll have an example. What is an example of something that is a perfect square? Someone read ahead, look at the notes. What is an example of a perfect square that I could write here? What is the general form? I still have the same 2 hands over and over. Look ahead in the notes. What is an example of perfect square? Just look down a little bit. Oh my gosh. Still only 2 people. Lorea.
49 minus 14x plus 2, or x squared.
Perfect. Thank you. And if I have perfect squares, then I'm going to use one of these 2 formulas, and then we need to write them all out. So write the formula again. It'll take a little bit of, I know that's not very much room, but you need to write these 2 formulas down here. Rewrite them again, please. Everyone is rewriting the formulas?
Can you scroll up a tab?
Yes.
Why are you behind? No, that's right. I think it's down.
Scroll down a tad.
Yeah, sorry. Because the fish tank was in the way.
Right.
It was.
That's one of the reasons I didn't want you to sit at your desk, but yeah.
Why is there so much hostility in the air?
Right?
I apologize. I shouldn't have been as hostile. Jaden.
Sorry.
All right, so we have all of the different forms, all of the different paths. So we have a total of 4 examples. I'm going to be doing examples 1, 2, and 3. You guys are going to be doing example 4. So in example 1, we have the square. We know it's a square, which means it is already a perfect square. And we know it has an area of x squared plus 8x plus 16. We need to find an expression that represents a side length. So I need to undo what's happening right here. I need to undo the square. How do I undo a square? How do I square root, essentially? Someone use our formula, your fancy-pantsy formula from up here and the one that you copied down as well. Use the formula, square root the first term, square root the last term, push those together with the correct sign in between. Anna?
X plus 4.
There it is. That is the side length, x plus 4. Again, it comes from square rooting x squared, which is just x, square rooting 16, which is 4, and then taking the sign for the middle term, which is plus. It's that easy.
So the 8x doesn't really matter.
The 8x comes from when you, I guess the 8x doesn't matter. It's the fact that matters is it's a positive 8x. And then we do need to check, does x times 4 times 2 equal 8x? Well, x times 4 is 4x, times 2 is 8x. So it is indeed a perfect square. But I'm only going to be giving you guys perfect squares, so we'll learn how to check that another time. All right, so we're on the back. Using the same formula, factor this as a product of 2 binomials. Use your formula. Use your formula. Okay, now you're going to pause and talk with at least 2 people. That means you're going to have to move around. Teach them how to do this if they don't know how to do it. Work with 2 people. Go. All right, example number 2. Who can teach Mr. Sindel? I give preference to people that have cards. We should all be seated back in our seats. So thank you, Chewy. Thank you, Anna. Thank you, Aurelio. Bev Cheetos, go for it.
Would it be x minus 7 or 7x?
X minus 7 like that? You are correct, but it's not following the formula.
7 minus x.
These both are the same answer. X, 7 minus x, quantity squared. These will both be correct on Khan Academy, and they are both correct in my class. Either way, it's fine. How'd you get 7, Beverly?
Wait, you took the square root of 49.
Okay, square root of 49, and how'd you get x?
Did you guys stop?
Please.
Can you guys please stop?
Thank you. Thank you, Mr. Sindel, for being so kind.
And square root of x, you get x, and where'd the minus sign come from?
The minus is from like minus 14x.
Yep. So usually most people will answer this one. The other one is still correct, but it's just less often. You don't use it as often.
And because it's squared, the negative, which would be a negative x or negative 7, that cancels out.
Right, yeah. So it doesn't matter if it goes x minus 7 or 7 minus x. The negative will always be positive for the first 2 terms, which is why the form up here always says a squared and positive b, a squared and positive b. All of them are positive because squares are always positive. Yes, Luria.
What happened to 14x?
So the 14x, I guess it gets used up when you factor this. If you want to check your work, what you can do is you can go 7 minus x, 7 minus x, 7 times 7 is 49, negative x times 7 is negative 7x, negative 7x, and negative x times negative x is a positive x squared. So when I do multiply these perfect squares together, you'll notice that I still get a negative 14x when I multiply them back together, but it's used up when I factor them out. You don't even use it. All you use is the sign. You just use the negative that's out front. Other questions on example number 2? All right, we're doing example number 3 as a class, and then you are on your own for example number 4. Number 3 and number 4 have a GCF, which is what you normally will encounter. What is the greatest common factor for example number 3? Hold up your fingers. What is a GCF? 4 people have it. 5 people. 6 people. What is the GCF? It is indeed 3. Who can factor that out for us? Raise your hand if you can factor out the 3. Colby, factor out the 3 for us, please.
25x squared minus 10 plus 1.
I think you missed. Yeah, there it is. There it is. Yeah, thank you. All right, so Colby factored out our greatest common factor, and now we need to turn this into a sum of squares. So this is going to be equal to 3 times something squared. What is that something? I see 2 hands so far. I see India and Ellery. Now I see Anna. Can I get anyone new, please? I would love for new people to participate. No one. All right, Ellery. 5x minus 1 is correct. And done. Box it. You guys are on your own for example number 4. Once you finish example 4 and check with at least one person, you may begin on the 2 assignments on Khan Academy.
So, first we need to take the GCF, which would be 2.
She just hit me. That's minus HP. It was a low pat.
And then that would mean you have 2. And in the parentheses you have 36 from the 72 plus 2 divided by 24, which would be 12. And you keep the x. And then you take the square root of 2, which would just be 1. And you keep the x, but this 2 drops because you square rooted it. And then you take the square root of 36 and 1, and you keep this sign, the positive, so that would be 2, and then 6 from the 36, plus, because we keep the plus from the 12, then you get the 1x, and then squared. That's very messy, but hopefully it makes sense. So I guess if you want Khan to accept it, you do this, and there, we can just drop the 1.